What up, gang? This week we're talking about additive compound area. Area. Last week we talked about quadrilateral area, all those six different four-sided shapes that we had. We talked about different criteria. We talked about how to calculate the area of them all. This week we're putting them all together for weird shapes, more like you find in the real world. It's not often we just have squares and stuff lying around, right? We did an example through the Google Docs that you should have read already. This is just an example of me talking through an example. It might be kind of more hardcore. Not really, though. It's all the same process. Over here, it took me like, I don't know, 20 minutes solid to draw these perfect little straight lines. Marvel, you're welcome. Kind of a big deal. Very proud. On this, we have this kind of pink, weird looking shape, all right? Again, the trick for compound areas, we take complex things like this weird shape and we cut it into things that we do know. So if we had this shape right here, this whole big old shape, I already kind of did it, but we cut it into smaller shapes that fit the criteria of those quadrilaterals. So for example, I could cut it right here and right here. Now we have three different shapes. I took one big shape and cut it into three smaller. That's kind of the whole process, the same trick you'll be doing for all these. Taking something complex, cutting it into smaller things that we do know. I'm going to label these. We got a shape up here, shape A, shape B, shape C. If I was to take this complex shape, split into those three things, we're going to deal with these individually, okay? So shape A, this one up here, it looks kind of weird. We got parallel lines, parallel sides. These two are the same. These two are the same. Call this a parallelogram because there's so much parallels going on. Parallelogram. From last week, our equation for the area of that is just base times height, right? So on this one, it's super slanty. We got our base right here. Using the graph, it's 1, 2. So we got 2 times whatever the height of that is. So from here all the way up. So we got 1, 2, 3. 1, 2, 3 has a height of 3. So this parallelogram has an area of 6. Complex stuff, split into smaller things. That's all we do. Same thing here in the middle for B. We got a rectangle. The angle got wrecked. Same trick. This equation should look familiar. We got base times height. For a rectangle, same thing as on a graph. We can just count the dimensions we need. As a base of 2 times our height. 1, 2, 3, 4. 2 times 4. So this shape B, rectangle, contributes 2 times 4, 8. 8 area here, 6 here. Keep going down the list. Third shape, my favorite, bees in the trapezoid. So our equation, this is the weird one kind of. This is that base 1 plus base 2. I think they had different terms, bases or whatever it's called. P and Q maybe? I can't remember now. This plus that is what that is. We times that by the height. I should start off with the starting equation like a good math teacher, shouldn't I? That's what I'm doing. Haha. Add the two bases. We times it by the height. We took that whole thing, cut it in half, divided by 2. All right. Base 1, base 2, the height. So base 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's 6 is our bottom base plus 2 times the height, which is 2. Because it's a trapezoid, we divide it by 2. 6 plus 2 is 8. 6 plus 2, so we get 8 times 2 divided by 2. 8 times 2 is 16 divided by 2. Half of 16. 8. Bam. This weird looking, I don't know what it is. It's like a robot leg or something. Sure. We split into 3 smaller shapes. Individually, those 3 shapes had areas of 6, 8, and 8. Okay? Because this bigger shape is made out of these 3 smaller shapes, the bigger shape's area is also made out of these 3 individual areas. So the total area in this case, we also call it the additive compound area because we are adding them. 6 plus 8 plus 8. Oh, why is this hard math? 8 plus 8 is 16. 22. I knew that. Ta-da! Shazam. Tomorrow, I want you to start a practice. There's only gonna be like two or three problems, nothing super many, but that exact same trick. Okay, you're gonna take something complex. You're gonna cut it to make it look more like those shapes, those quadrilaterals last week. You're gonna find those individual quadrilateral areas. And because we're talking about additive compound, because our shape is made by adding these shapes together, you're gonna add them for your total. Do that exact same process. Okay, so for the 2 or 3 shapes you're gonna have practice on, tell me what the individual shapes are. Show me your work. Add them together for the total. You dig? If you have any questions, you should know what to do. Email me. Thank you.